A sample of a basic triangle proofs congruence only no CP/CTC problem. We're going to start with the givens. AC is perpendicular to BD and BD bisects AC. Those are the first statements here and they're given. So I'm going to be asking myself, what does this mean? So what does it mean for AC to be perpendicular to BD? Well, remember, perpendicular lines form strictly 90-degree or right angles. So I can actually say that ADB is a right angle. And the reason for that is that perpendicular lines form right angles. We're going to try that, and wow, it worked. Now, let's see what happens if we do something wrong. So if we say like ADB has to be congruent to BDC. This is technically true because we can say all right angles are congruent. Oh no, but here's the problem. One of the two angles that I've mentioned, I haven't said that it's a right angle yet. So we need to say that first. Well, I already did ADB. So the other one is CDB. So we're going to make the statement that CDB is a right angle. And it's a right angle because perpendicular lines form right angles. And see, when I try that one, it goes through. So now let's try to say that those two angles are congruent. ADB is congruent to CDB. And the reason for that is that all right angles are congruent. Fantastic. Now see that when we highlight this, it marks those two angles as congruent for us. The next statement that I want to work with, because I've done everything I can with these being perpendicular, is the fact that BD bisects AC. Now, a bisector cuts a segment into two congruent segments. So we're going to say that segment AD is congruent to segment CD. So AD and CD, and maybe I picked the wrong reason here. What happens? Oh no, to use the transitive property for congruence, there must be a third line segment that has already been established to be congruent to both of those. That tells me that that's the wrong reason. Doesn't mean that this is the wrong statement, so I can try a different one. In this case, we actually already knew that it was a segment bisector divides a segment into two congruent segments, but I want you to see how you can use this to learn and fix any mistakes that you're making as you go through this process. So we're going to try that, and wow, that one worked. Awesome. I'm looking at these two, and I don't see anything I can say about angle A or angle C, so I must have something to do with like this segment here. And BD is actually a part of both triangle ABD, this triangle here, and it's part of triangle CBD, or this triangle right here. So we are going to make the statement that BD is congruent to itself. Now, the reason I can make that statement is the reflexive property. The reflexive property lets me say that a segment is congruent to itself. So we're going to try that, and it worked. Awesome. So now if we're looking, we've got a side, an angle, and a side. So the reason that I can say that these two triangles are congruent is because we've got the side, angle, side theorem here. So we would say that triangle ABD is congruent to triangle CBD. And the reason we can make that statement is the side, angle, side theorem. And that worked. And so now that we've done that proof, we can come down here, hit submit answer, say yes, we got our green check mark, and we can go on to a new problem. You do the same thing with this. Break it down with what you're given. So here, D is the midpoint of AC. We've got segment AC. That means that AD and DC are congruent. So let's start with that segment. AD and DC are congruent. I can say that because a segment bisector divides a segment into two congruent segments. Oh, I wrote it wrong. We can say that because a midpoint divides them. See? Got to make sure we're paying attention here. D is the midpoint, so we got to use midpoint there. We don't actually have we didn't establish that ED and that FD are the segment bisectors, but they are as well. Okay, so now that we've dealt with D is the midpoint of AC, we can deal with the fact that ED is congruent to FD. And that's already given, so we are good. And we're given those angles, so it looks like we have a situation of side, angle, side for these two triangles, AED and CFD. So we can actually go straight to making the statement, because you can tell if we highlight these. So we've got an angle that's in the green there, side, angle, side. Once again, we've got a side, an angle, and a side. So the angle is between the two sides. So we can say that AED is congruent to CFD. And the reason for that is going to be the side angle side theorem. We can click try. Oh, CFE, whoops. CFD, typo. Try that. And we have proven that those are congruent. So we can now submit our answer, say yes, and keep trying. So even if you make a mistake, use the hint that it gives you to help figure out what was wrong. It told me that it wasn't a proven triangle, so I realized I had mistyped this part. Not that part, this part. I had mistyped this and typed in E instead. So use the hints that it's giving you to help you understand what's going on. So let's look at a new problem. Here we've got AC perpendicular to BD, and we're told that DB bisects angle ABC. Those statements are there because it's given. Now, since AC is perpendicular to BD, I actually know that ADB is a right angle, because perpendicular lines form right angles. We can try that. Awesome. We also know that angle BDC is going to be a right angle, because perpendicular lines form right angles. And now that those are both perpendicular, we can say that they are equal to each other. So we've got ADB congruent to BDC, because those are both right angles. And we're looking for all right angles are congruent. Try that, and it worked. Awesome. Okay, so up next, we took care of that part. Oh, hey, wait. Notice that BD is part of both of those. Let's use that next. So we've got BD congruent to BD. That is the reflexive property that makes it congruent to itself. Perfect. The other thing is that DB bisects angle ABC. Now remember, bisectors cut things into equal pieces. So we've got to name those two angles. ABD is this angle right here. And then CDB is this angle right here. And those are going to be congruent because an angle bisector divides an angle into two congruent angles. Oh, I typed that wrong again. Whoops, CBD. There we go. That's referring to this angle and this angle. So see, it's okay if you make mistakes. You just got to figure out, well, why is that a mistake? What's wrong? It gave me the hint that that wasn't the correct one. So when I checked here, I was like, oh, B is the vertex for both of my angles. Let me fix that. Okay, so now we're going to keep going. The next piece here, we've got an angle, a side, and an angle. Look, angle, side, angle. Angle, side, angle. That means that these two triangles are congruent, so I can say that triangle ABD is congruent to triangle CBD. And I can say that that's the case by, once again, angle, side, angle, because the order of them in the triangles is angle, side, angle. We're going to try that, and now we've proven it. We've got a check mark there, and we can submit our answer and keep going. Okay, so you only have to do 2 of each type, but this is the kind of thinking that you should be doing while you're doing these problems.